All right, let's get started. So it's been a while since I've seen y'all. We're about halfway through the course right now. So you should already kind of be pros at this, right? A lot more so than when we first started a few weeks ago. So how do we feel so far? Or something starting to make sense? Like, does the earlier part of the course seem a lot easier now, which was kind of stressful at the time? But now that we use the code over and over, do we feel better about some of the stuff from the start? A lot of blank faces. Okay. Okay, so arrays. How did we do with arrays? Multi-dimensional arrays, accessing data, setting values in arrays. Do we have any questions there? Cool. Okay, so let's do a quick review on objects and scope, which is going to start to play a much more important role as we begin to use these complex data types. And then we will go into methods, which is the topic for today. So can somebody tell me in English, what is an object?
It's a set of key value pairs.
Yeah, exactly. We call it a collection of key value pairs. And so the keys over here and the values go on the other side of the colon. And together, the pair of a key and value make up what's known as a property on the object. So how can we access some of these properties on the object? How can I log out the name of this person? Okay, so what does this look like with dot? Exactly. And what does this look like with bracket notation? Exactly. So all that's going on here is we could put any type of expression inside of these brackets. And at the end, whatever that expression is, it needs to evaluate to a string. Then as soon as we pull down to a specific string value, or in this case name, it basically just goes and does person dot with whatever that string value was. So it ends up working the same as dot notation. But this gives us the ability to dynamically access properties that we might not know when we're writing the code, which properties we want to access. So an example of that is, let's say we had some variable called myProp. I can now plug myProp into here, and what will line 16 result in? 25. So the order of operations here is we need to solve this expression. So we look up on the scope, and we'll see that my prop is on the scope, and it's set to age. So this resolves to the string age, and we do have a property called age. So when we plug the property into the object, we get the value. So line 16 would result in 25. And now elsewhere in my code, that prop can change to now be name, and the same code will still run and successfully get that value. So this is really powerful stuff, being able to dynamically express the properties we want to access. And so in general, we should prefer to use bracket notation, and we should really only use dot notation for properties that we 100% know are present on the object. So in this case, I know I created this object. I know it will always have a name and age. I can use dot notation for those properties. But later on, I may add other properties to that object, and so the code dealing with that is safer to go through bracket notation. Does that make sense? Cool.
The dot notation has to be like exactly.
It has to be exactly there. Yeah, you really need to be sure that it's on that object. So with any data types that are going to change and be mutated, it's safer to use the bracket notation. But with something like this, console is an object given to us by JavaScript. And it has a log property, and we know it has a log property. That's part of its API. It's not going to disappear unless I play with that. So here, dot notation is perfectly acceptable in that sort of example. Now, scope. How did we feel about the scope lecture? Did we draw out the scope as we go? Have we started to keep a mental list of the scope? Yeah? Okay, so that's something that we need to talk a little bit more in depth about because the way these complex data types work is a little different. So I'm referring to this idea of pass by value and pass by reference, which I'll illustrate in a second. And this is kind of annoying because tomorrow's lecture is on pass by reference versus pass by value. But today we kind of need to understand it because we're going to work with these object methods. I'll explain in a second. So I'm going to go through this quickly, and then we'll really hone in on it tomorrow, but try to bear with me here. So we're going to do a little scope review. So this is my entire program. As soon as we run the program, before it even starts to interpret instructions, does anybody know some things that the compiler does for us? What about with, yes? Hoisting, yes, exactly. That's where I'm going with this. So, as soon as our program runs, it looks specifically for variable declarations and for function declarations. So you may recall that if we have this special function keyword, as soon as the program runs, it kind of already saves that into memory for you, which gives us this ability to call myfunc up on line 19, even though it doesn't appear to be defined until line 24. Now it's also doing that for variables and let and const and any piece of data that you're going to save. So at the start, as soon as we begin to run this code, the compiler is going to come over to the global scope, and it's going to say, I need to remember something called myfunc. And this one is actually equal to a bunch of code in here. It will set myfunc equal to that code. Like it will pair them together because it knows here that that's not really dependent on any code actually running. This function is going to be whatever instructions are in here. Now with variables, it's a little bit different. So it's still going to hoist my var, but before the program runs, we're just going to come over here and make space in memory for something called my var. But at this point in time, the value is not determined. My var is undefined. JavaScript just knows that that it needs space for that, and it will get set. So it makes that ready for us on the scope. But it can't just give us this value 10 right off the bat before the program runs. It's not going to execute that. Because over here we could very well have 10 plus user age. And so when the code first runs, it has no clue what user age is. So that's why we can't set values of the variables at the start, but we will put them on the global scope and make some room for them. And so that allows me to actually run this code without an error. On line 20, when we try to access my var, we are actually able, the code does know what my var is. We've signaled that that needs to be a piece of data. And so right now it's currently undefined, but we were able to access it. If I uncomment this and I try to run the code, when the program ran, it didn't see any declarations for anything called my var. So this would not appear on the global scope. We never said this is something of significance that will have a value. So when we try to access a variable that we never defined anywhere, we get an error. Whereas in the other case, when we declare that we're going to define it, its value isn't set, but we can still access it because JavaScript is aware of a thing called my var. Does that make sense?
Yes.
Question?
So when you're talking about hoisting, and you bring the functions up and you bring the name of the variables up, when the function goes up, it doesn't execute in that order?
No.
Right? So it executes later. So what does it mean for the function to be up there?
It means that we have access to it. Anywhere in this program, we have access to it. So in this case, we have a function that's going to do something. And unlike my var, I can actually run my func right here on the very first line of my program. Because it knew over here that this is like a code recipe. This isn't going to change based on what calculations I do in the middle. This is pretty much hard-coded that my func is going to do the code in between these code blocks, which is why it can immediately make that available to us. With my var, however, this is a calculation. It's not going to perform calculations until it's actually executing the code, because they're dependent on other aspects of the code that it doesn't know what that behavior is going to do until it tries to actually run it.
What about if the function has variables?
So if the function has variables in it at this point in time, it doesn't matter yet. If I haven't run my func, the compiler hasn't looked at that at all. So let's pretend in here I've got So pretend that we just set up our scope, we've put the instructions along with my func, now the code begins to execute. So on line 19, we say begin to execute the code inside of my func. Now it does kind of the same process it did with our whole program. Before it begins to come in here and execute these commands, it's going to make a functional scope for my func over here. That's going to roll through here and look for any functions that are defined or any variables that are defined. So at this point in time, it's going to make space on this scope, not the global scope, but on the scope related just to this invocation of the function. And so x is currently what? Right before the code actually executes, what is x set to on the scope?
10.
Not yet. Undefined. And that's happening because it scans through this code and it sees that we're defining we need space for something that will be x. But we haven't run this code yet, so this assignment operator hasn't been performed. We don't have a value to give to x. But this means that I can now run it, and it will log out x as undefined. Or I am entirely wrong on this one. Maybe it does not hoist the variable inside of the functional scope. What? Yeah, that's why I'm confused right now. Do I have an x somewhere else? Yep, okay, so it doesn't hoist the local variables, but either way, we still make a functional scope. And so now on line 25, it actually makes space for something called x and sets that to undefined. And then we start stepping through this code. We can log out x as undefined. We can now set it as 10, so we'll come over here and set it equal to 10. And then down here, when we say do something with x, we need to evaluate what x is. So it starts on its innermost scope, which in this case is my func. And we'll look over here and we'll see that x is currently equal to 10. So we'll take this value and we'll plug it in here, and now we can go to the console log function to actually do that. Then as soon as we hit this line over here on line 29, it comes over here and it erases this entire scope. This is completely gone. It's garbage collected in JavaScript, and now we're back out operating on the global scope. So that was like I was just trying to show an example about the hoisting. It wouldn't really matter the way we use the variables inside of the function. We wouldn't take advantage of the example I tried to demonstrate. But I guess that's good to know that it only hoists variables on the global scope. So there's one trick here that's we're going to talk a lot more in depth about tomorrow. But complex data types work a little bit differently. Now when we run this and we come here, we have some space in memory for something called my arm. But we don't know what that is yet until we solve this right-hand side of the equation. When we hit this bracket here, it calls a constructor to create that array. Same idea with an object. When we hit the curly brace, it calls a JavaScript constructor to actually make that type of data. And what JavaScript is going to do is it's actually going to go over to something called the memory pool. And it's going to go to the first available spot in memory, which in notation we're going to call it 0x0. And this is where that array is going to actually live. So in memory, we have this complex data type with the values 1, 2, 3. And now as soon as we complete that constructor, this memory address is actually what gets put on the variable over here. And so now I can make another variable that we can call the same array, and we could set this equal to my r. And so what happens here is when we need to figure out what my r is, it steps to the global scope and says, okay, my r is this memory address at 0. So same r is also going to point to the thing at memory address 0. And the reason that's useful is because now I can come down here and I can push in the value 4. So what's going to happen to execute this is it looks up my array on the scope. It says, okay, I'm operating on the piece of data that's at memory address 0. So we come over here and we mutate this and throw a 4 in there. So now if I want to log out same array, right below it, we see that same array, which might appear like a different variable to you, actually sees the changes that happen when we push 4 into my array. And that's because both of these variables are pointing to the same spot in memory.
If you did console log after you did push 4 of my r, would it just go back to the original array?
If I console log line 34,
If you console log instead of same array, my array, after you've done the my array push.
yeah, so both of these will look up on the scope and see that they're at memory address 0. So we'll pull that array out of the memory, and that array is going to have 1, 2, 3, 4, regardless whether I access through my r or through same r.
So why do you need to add line 33 for?
Because,
Instead of just using.
okay, so a real life example would be in our application, we've got Facebook, right? We have all sorts of different user objects. And when you log in, I'm going to say, hey, my user is equal to your user object. But elsewhere in the code, like in her code, she has best friend, and best friend needs to point to a user object as well. And so we'll have many different variables all pointing to user objects. You've got the currently logged in user, you've got yourself, and you've got your best friend. And so those are all doing different things, like we're going to log in the current user. But when we log in the current user and change that user's name, you still need to see that when you look at your best friend. You need to see that when she logged in, she changed her name. So what best friend is to you and what currently logged in user is to you both point to the same place. And only because of this ability to pass a reference means that we can refer to a piece of data with different variables and share their state. Let me demo. So here we're creating an object to represent me, and we have a piece of data that will be used to refer to the logged in user. And now we have a function called logInUser that's going to take in a user object, and it's going to set the logged in user equal to that user object. And now over here, somewhere else in our application, we have a function called changeName. And it's going to go to the logged in user and update their name. So this is a really quick example of what's happening here. Somewhere we've got a collection of all these different user objects. Right now, I'm only showing you mine, and it's got a property called name. When I log into Facebook, it's going to set this reference, logged in user, to be equal to that user object, to point to the same spot in memory. So when I pass me into here, I'll just illustrate this whole thing. So as soon as we define me over here, we took the first available spot in memory, which was memory address 0, and we said me is now pointing to the object that lives at memory address 0. Then when we call login user, we pass in me, and login user will know that as user object. And it says, hey, on the global scope, change logged in user, which was null, but set it equal to the memory address that you're giving me, the person who's trying to log in. So login user will now be 0x0 as well. So through the logged in user, we can make changes to this data type, and that will be reflected everywhere else that's pointing at that memory address. So if we change logged in user's name, and we go back to me, because they're both pointing to the same place in memory, that change is persisted. So when we come down to change name here with the string Adam, it doesn't care who me is. It doesn't know that. It just knows that it's going to change the name on whatever is currently known as logged in user.
Will it retain the original information?
No. So in here, we say go to logged in user and go to name. We look up logged in user. We see that it's memory address 0. We come over here and we completely overwrite that value to be Adam. Anywhere in the app or in your versions of Facebook that are pointing at this user that's at memory address 0, when they try to access this now, they'll see that the name property is, the value of that property is Adam. And that has been updated everywhere. And this would be impossible to do without references. If that object can only exist on one variable, it's a lot harder for us to share data and persist changes. We're going to do like 100 examples of these tomorrow, but I don't want to go through the rest of today without putting that in the back of your head just to flip it upside down tomorrow. So the main takeaway here is that when we have primitive data types, like just a variable called my age, and we set that equal to 10, the value is that actual primitive data value is the result of that variable on the scope. But with complex data types, they're a reference to somewhere else in memory. And so changes will be persisted across all references to the same data object. Yes?
Do you mind returning to the function you created before on my phone? So on line 27, when you set the value of x to 10, aren't you declaring it globally?
No, because in that case, on my func, so in the functional scope there, when line 25 runs, we made space in memory for x on this scope. So to illustrate that, we've got an x on the global scope that's set to 100. When we step into a lower scope and we refer to a piece of data, it first checks to see if that thing exists here or not. And if it doesn't exist here, then we'll go to the global scope. And if we have a let declaration, it's going to declare space in memory for whichever scope you're currently operating on. So as soon as I say let x, we're now going to add an x to this functional scope. So then on line 27, when I say x is equal to 10, it checks its nearest scope first, this functional scope. It says, hey, is there an x on here? And if there is, its value is now 10.
So if you deleted line 25,
Yes.
would line 26 return 10?
Yes, it would. I'm sorry?
You said yes if it would return 10. You said yes.
Well, x is value is 10. I haven't put a return in here. So what happens here is when we go into my func, this time there's nothing on this functional scope. And when we hit line 28, it says, hey, go find x on the scopes, and the first one you find, set it equal to 10. So it checks its functional scope first and says, hey, do I have an x? I don't have an x, so let me make my way back out to the global scope. And so on here, we do see that x was 100, but now we're saying change this x to 10. So it drops off this 0 here.
But it logged out 100 there.
On which line?
On the console.log. So
Because these are executed in order, right?
I thought
So
that-
at this point in time that we run 27, x is still 100.
I just thought when you declared a variable within a function without a let, you were assigning it globally, and that it applied everywhere. And if it applied everywhere, it would apply when you began the function, and therefore make the x.
Okay, well,
prior
it
to
is
the
true if we
declaration.
if we just add a variable in here and set it equal to whatever, without the let, it would define it on the global scope. But in this case, x has already been defined on the global scope and given a value of 100. At the time we begin to run my func, x is on the global scope at 100. At line 27, we say, hey, go find x and log it out. We check the functional scope, and there is no x in here. These are done in order. This does not happen yet.
Okay.
So when we execute line 27, we don't find an x on the functional scope. So it says, oh, you mean the x that's on the global scope. And we find this one, and we log out x is 100. On the very next line, on 28, we do the same thing. We say, hey, find the first x you can, and reassign it to 10. We don't find it on the functional. We do find it on the global. So now on the global, x will be 10 until the next time it's assigned.
So if you deleted 23, on 23, would it return 10?
Okay, so let's be careful with the word return. What do you mean?
If it would log out 10 on 27.
Okay, so at this point in time, again, there is no x on any of the scopes yet. When we first step into my func, it's going to look for an x that hasn't been defined yet. So I'm not sure if that's going to throw an error. It's going to say undefined, but the only thing I do know is that it's definitely not 10.
So when you're declaring x globally within the function, it only applies after the function is run going forward?
Well, yeah, we haven't run that line of code yet at 28.
Okay. That's what I
And so we see here actually that, yeah, when we come to line 27 and we say find x, there is no x over here. And there is no x over here, so there's no x anywhere. It has no clue that the next line is about to define that. It says I can't do anything right now. So it's an error.
I was under the impression when you declared globally it applied everywhere, even if you hadn't gotten that
It will be everywhere once we execute
Right,
it,
yeah.
but it's not defined until we run that line of code.
Yeah, I appreciate that.
So if we move that up like that, x now does get set. And because we left off the let, it's actually not going to put it on the functional scope. Like you said, it will default to the global scope. So on line 27, we add x to the global scope as the value 10. We log that out twice. And now actually out here, because my func has run, my func has now saved x on the global scope at 10. So after we run my func, I can now log out x back out on that global scope, and we will access it because we have ran that line of code to actually put it on the global scope. Yes.
So to this point, like for a for loop, you always say for let I equals 0.
Yes.
You don't put the let.
If you don't put the let, that I will be on the outer scope, the global scope, and that means that when you're done, after you go through the for loop, you can still access I, and you'll see the final value. Whereas if it was declared with let, it's getting block scoped only to the for loop. And as soon as the for loop ends, it cleans up all of its own variables. In the case you let off the let, it's defined on the global scope, and it doesn't get cleaned up. Yes.
One question just about memory. If memory is allocated for every variable that is declared, I'm wondering if kind of the amount of memory that is being used is negligible, or for coders like at your job, do you try to limit the number of variables you declare ultimately?
Yeah, so there's this concept of space complexity, which means how much space do I actually take up to run my code. So it is something to be conscious of. That being said, it's not going to really come into play other than when you do huge recursive calls or a lot of data work. For most of our applications, we don't have to worry about space complexity at all, just more so for algorithms that are actually doing a lot of processing. So right now, there's no consequence to using as many variables as you want. I feel like there's another part of your question I missed, though.
No, that was it.
Okay.
I think that's why functional hoisting is not working, because you are using left. But if you use var, it would work.
Nope.
No, but console log is before.
Oh, am I still... Wait, where do you want me to go right now?
So console log x before declaring it.
Well, this does the same thing,
Oh,
but
it's undefined.
I don't... Why did it just error out a second ago then?
No, you have to.
Oh.
But it will hoist if you use it.
Okay, so they took that out then with let and const, but variables will hoist themselves within the function.
Yeah.
And the last error I just got was because once they added this bar here, that x only existed in this scope and not out here. The error was from there. You were correct. Okay, so again, we're going to do a whole lecture with like 20 examples of this, but I'm now going to illustrate the problem with how we need to refer to these complex data types so that we can understand these methods. And so that's why I had to do this little sideshow. Anyway, today's class is on methods. Does anybody know what a method is? Yeah, very close. So a method is a function that exists as a property of an object. Yeah, you are correct. So log is a method on the console object. So today we're going to make our objects a little bit more usable. We're going to make them smart and have the ability to do things. So in this case, I have people objects or I have user objects again, and I want to give them a method that's basically going to log out their name. So this is a method because we have a property that's called sameName, and the value is a function, which means that I would be able to access that method and invoke it. But right now it's not doing anything. Does anybody have any ideas how we can make this sameName method log out its name?
So we would return user.name.
Or let's just log it out, but yes. So this is the start, this is the naive implementation. I'm going to demonstrate why this is a problem. But yeah, right now, let me just block off all this code from above. Yes, right now we now have defined the sameName method, and when we access user and we go to that property, because it's a function, we can invoke it. And when we invoke it, it will come in here and log out the user.name. So to illustrate this problem now, we need to go back to the scope and tie it together. So on line 64, when we declare user, we come over in memory and we go to the first available memory address, which is memory address 0. And we declare this object that's going to have name Chris, and it's going to have the sameName function on here as well. And we get memory address 0 over here. So when we go down to line 71 and we say user.sameName, we do go to memory address 0, and we do go in here to sameName, and this thing is going to user.name. So to analyze that, we look on the scope for user, and we see user is still memory address 0. So we come back here, and we can now access the name. You see there's kind of like an extra step here. It needed to look up what user was and figure out what user was. It didn't necessarily know that it's the name on itself. And that's the problem we're going to solve today. So while this does work,
So you're trying to use this document?
yes, that's exactly where we're going with this. The this keyword. We're about to cover it in a few minutes. I'm just going to show why this doesn't work and isn't sustainable. So let's say on line 74, we said user 2 is now whatever the value of user was. So we're putting user 2 on the global scope, and user is currently memory address 0. So we take user 2, and he's now memory address 0 as well. One thing that's worth noting, when we compare complex data types, we see this user 2 is exactly equal to user. That's true. It's not looking at the properties on the object. It's comparing the memory addresses. And in this case, 0 is the same spot in memory as memory address 0, so they are exactly the same. In this example down here, we create two objects. So we're going to get memory address 1 is an object that has the property A and a value of 1. Then we go to make other sample, and that will be memory address 2 with the property A and the value of 1. But when we go to compare them and say, hey, are these exactly the same? We would maybe think they are because they've got the same properties and values on them, but JavaScript says no. Memory address 2 is not the same as memory address 1. They look the same, but they're not. If you make a change to one, it won't show up on the other because they're completely different objects. So when we compare complex data types, we're really comparing if they're referring to the same exact thing in memory.
Within the object, within the one specific object.
What do you mean?
Like you said, they may look the same, but they're two separate objects.
Uh-huh.
So it would return true if they are exactly equal within the same specific object.
Exactly, if they are the same object, which means pointing to the same spot in memory.
I wanted to ask you a question about line 66. What is line 66 doing?
66? So in 66, we're defining a property on user. It's got the key say name. And then on the other side of a colon, we can put any value. And a function is a value just like a number is just like an array. So here we're defining this value, this function. And so what we're saying is, hey, when you access this object at the say name key, you really want to be using this function. So all I'm doing is defining a function that lives inside of that object.
Well, what is the function doing there in line 66?
What do you mean?
You're saying it's defining a function to do something in action.
Yeah, this function's only just going to log out user.name right now. That's all that it's doing, but nothing happens. When I first define this object, it just puts this function in memory with the same associated with say name. It doesn't actually run this code. That doesn't get run until 71.
So it's the function at that point after say name is being defined as user.name.
On 66, we're just defining a function. That's all that keyword is doing. It's making its space to exist in memory on that object.
But it hasn't been specified what that function is going to do at this point.
Well, I have the coding there that says what it will do when we invoke it, but right now it hasn't done any of that.
So that's what I'm saying. So what I'm saying is it's going to become, or it's going to be invoked as user.name. You're making it that value.
Do you mean the function will be invoked?
Yeah.
The function will be invoked with user.sayName. And when it gets invoked, that function is going to use user.name inside of it.
That's it.
Okay, so do we understand how we test for equality with the complex data types? What is it actually checking to see if they are the same? It's checking their reference, their memory address. So if we go back to this example over here, we have now given user 2 whatever user was. So user 2 is now pointing to the same memory address, and we log that out and see that they are the same. Yes?
Why do you create the function within the object
This was just to really demonstrate that it's inside of the object, but hypothetically we could have said we could have passed any function over here. But I think that that's a little less readable and a little less clear. With the way I do it just now, I think to me this signals a lot better that this is a function that exists within the object and really should only be used within the object. So it shouldn't be declared out here. Because eventually what we'll get to in a few minutes is it's going to refer to the object it's operating on.
So you want it only to refer to that object.
Yeah, I think stylistically to actually define it inside of the object makes a lot more sense. Or maybe you were asking why do we even have the function as a value in the object?
Yeah. So you have to call it with the object name anyway.
Yes, but inside of the function, that code needs to know what it's referring to, which we'll cover in a second. But I guess your question is why write a method when you could just write a function? So methods are functions that exist within objects to have a special purpose to interact with the object they reside on. And we're going to use a keyword, as I mentioned, in a few minutes that makes sure it's locked to itself. But I have to demonstrate the problem with how this is set up now first. So down here, we made user2 equal to memory address 0. So we know that this is the object that lives at memory address 0. And on line 8, or 80, down here, I'm saying the variable user is now equal to null. So we come to the global scope, and user is now equal to null. But user2 is still pointing to this thing in memory. This object still exists, the first one I defined. I can just only get to it as user2 right now. So on the next line, I can just demonstrate that we have user2. We see that we still have a way to get to that thing in memory. But what's going to happen when I call user2.sayName? So we do reach this object in memory at memory address 0. We do start to process these instructions. Except inside of this object, we really wanted it to refer to itself. But it was referring to user because that's what we named that variable. Later on in the code, stuff has changed. User, this variable is no longer an object with a name property. User is null. So when we try to access user.name, it plugs in null over here and says null does not have a name property.
Where does it do that in the code on line 80?
On line 80, yeah, I basically made that variable useless. And because we had hard-coded in, look at user, when we go to do this now, we can't say the name of that person anymore because that was dependent on variable names and not the actual data.
So in line 81, when you invoke it as a function, that's when it returns back the error.
Yeah, that's when we step in here to actually process these instructions. And so earlier, when I called user.sayName, user was still memory address 0. And so when we got in here, it still went to that memory address and could log the name. Down here, I just got a new variable to point to that object so that I could still call this method. But now when we call that method, it's hard-coded to look at a variable called user. And that doesn't exist anymore. Really, we don't want to just always look at user. We want to log out the name on this object.
So if you would have just switched lines 81 and 80, then it would return the actual user, it would return Chris.
Yeah. So when we run line 80, it says, hey, look up whatever user2 is. We find memory address 0 is user2. We go over here, it says object. We go into sayName. SayName is still referring to user. We come back out here, user is still 0. It's not null right now. We go back again, and we can access that name. It's kind of a roundabout way of getting there. Instead, what somebody mentioned before is there's this thing called this. And this is the highlight of today's lecture, but it'll make a lot more sense when we get to the slides. So we can go back to our example where we've now made user null. But user2 is still a reference to that object in memory. So with user 2, user is now null, but user 2, we can go call the sayName method. And we come in this object, and we come down to that function. But instead of hard coding to look at user, previously it was saying user, so we jumped over here, and then back, and then looked for a name. This says just go to this dot name. And this is a special keyword that exists in objects that says, hey, wherever I'm currently operating, just look at what I am. And so this refers to this memory address. We don't have to keep variables hard-coded to refer to things. We can change our variables, and as long as we have a way to get to this memory address, whenever we call sayName, it will just refer to its own name.
Then why would changing the value of user to null on line 80 override
In this example or before?
in that example?
Well, in this example, it's only overriding that the variable user no longer points to 0, it just evaluates to null. We don't use it anymore because sayName is now looking at this. We're not depending on that user variable still being the same object.
When you talk about memory, you're just talking about local scope versus global scope.
Yeah, so the memory pool is just like an additional step where complex data types live. And variables that are set to complex data types are actually pointers to where that thing actually lives in memory. And that means we can have multiple variables point to the same object, and we can update that object, and all of them will be changed. It's not like this, where I say, let age equal 100, let my age equal age, and then increment my age. Any ideas on what the age variable is going to be on line 91? No. So we do line 88. We set age equal to 100. Now this is where the big difference is. We define my age, and we're saying my age is equal to whatever the current value is of age. So my age is now 100. Now on the next line, we say, hey, go to my age and just increment that value. So my age was 100. We now make it 101. But this has nothing to do with the original age because these things are passed by value. When I set my age as equal to age, I'm not getting a reference to the age variable. I'm just getting the value that age was at that point in time, which is how I initialize this to 100. Any future changes to my age will just change the value of my age, not this age. Objects let us have multiple variables all pointing to the same place, and they'll all persist data changes.
So age just stays 100.
Exactly. Age is 100 on line 91. We haven't said go to the global scope and change whatever age is or mutated in some way.
I think just one of the issues with the confusion, and I totally get what you're saying, is just the verbosity of the conversation where it can just be narrowed down to local scope, global scope, so it's a little bit easier to understand. Because I understand about the whole memory, space holding, and all that.
Yeah, we're going to do like 20 examples of these tomorrow, step by step. But I think we need to have an understanding of references to talk about the this keyword. And honestly, I think these lectures need to be flipped. But, okay, now we've introduced it. We can move on to the slides. And then after that, we'll show how this is useful in real life to make multiple different objects, or phone books in this case. In this case, we're going to have a phone book, an object that represents a phone book, and they're able to add numbers and remove numbers. But because of the this keyword, I can now make multiple different directories that can all have an add number and remove number that will update only themselves. We can hold that thought. Any dying questions? I know that this seems like a lot. It's like 2 lectures worth before we even start one. So if there's anything to clear up, I can clear it up now, else we can move to the slides.
94, I don't understand why there's a curly brace when I thought it's supposed to be a string.
So directory here is a key. It's a property on phone book. And I'm setting that value equal to another object that's actually going to represent a mapping of numbers to names, which we'll cover up later. Anything else? All right, object methods. So what is a method? A function that lives on an object, and it should be doing some action that's related to that object. We'll have a few examples here where the methods are totally useless and should not be methods, which we'll talk about in a second. So we're going to go over how to create these methods, how to access them, and how to run them, and then talk about this magical this keyword that is very scary in JavaScript, but it makes things possible. So methods are actions that you can perform on a value. In other words, on an object. They're functions that live on objects. We've been using methods throughout this course, like index of. So index of is a property of the array object, because under the hood, JavaScript codes almost everything as objects. So when we say myArray.indexOf, and we defined our array, JavaScript went in there and it added a property called index of that would perform some work on that exact copy of the array. So JavaScript gives us a bunch of methods, and we use them all the time. Like the log function is a method on the console object. So most of these methods are built into JavaScript. We don't have to define them ourselves, except for when we need to create some real-life functionality, like a phone book directory. So over here, we've created a variable called countries, and countries is an array. Under the hood, arrays are actually objects. So JavaScript was able to go add a property called index of. And inside of that index of property, which we haven't covered yet, but it's using the this keyword. And that's how it knows how to access this data. Index of uses this to be able to find this data and loop through it. And so when we go to look for the index of Brazil, it goes 0, 1, 2. I found it. I'm going to return the index 2. So we can create our own methods as well. We just have to define objects and set a value equal to a function. So this one, they didn't do it, but here we're creating an object called Grace Hopper, and we've just got 3 properties on there. All of the values are strings, and they're accessible by first, last, and rank. So these don't have to be strings. They could be any data type. They could be null. They could be a function. They could be an array. And if we add a function to this object, we now say that the function is a method. It's just semantics to describe a function that exists on an object. So in this case, we're actually going to define a method. We have a 4th property called myMethod, and we're setting it equal to an anonymous function here. This is just a function that doesn't have a name built onto it. We'll access it through myMethod. And so this is an example of a pretty useless method, because inside of here, we're not really doing anything that's related to Grace Hopper or this data. It just exists to say I'm from a method. And so if we want to invoke this thing, we can go to the Grace Hopper object, and we can access the myMethod property. We know it exists there, so they're using dot notation. And because we know it's a function, we get the ability to invoke it. So when we invoke this, it just logs out, I'm from a method.
It just takes it from the console log, the string from the console log.
Here? Yeah, when we call a console log, whatever the expressions evaluate to is what gets logged out. So we've just passed in a string value, I'm from a method, and that's what gets logged out up there. Yeah, so the log is a method on the console object, and it's going to just, it has the code inside of it to draw on the screen whatever data type we passed in. So methods on an object generally should perform an action that's relevant to the idea or concept represented by the object itself. So in this case, we have a function called sayQuote. And in here, I guess we're going to log out a quote that was said by Grace Hopper. And so because this specifically has to do with Grace Hopper, this sayQuote function should live on that object. Any ideas on how we can invoke this? Yep, Grace Hopper dot sayQuote to access the property, and because it's a method, we can invoke it. And so when we do this, it will log out a quote that was related to Grace Hopper. So it makes a lot of sense to have this function exist on that object rather than have a function somewhere else called sayGraceHopperQuote. We should only be able to do this through the Grace Hopper object. So now we've added another one, and this one is called get age, and it's going to give us the age of Grace Hopper. And so inside of here, I guess they've kind of hard-coded that she must have been born in 1906. So anytime you call this function with a year, it will subtract the 2 and return how old she was at that year. So this is again related to Grace Hopper, and so that's why it is a method inside the object. So we access it in the same way, gracehopper.getAge, we pass in 2018, and we get back 112.
And the idea of this is that it reads like English, that it's like, that when someone else looks at it, it's just more intuitive.
Exactly, yeah, you don't have functions all over the place that are related to all sorts of different things. Everything related to Grace Hopper exists where we define Grace Hopper. And so when you invoke it, it's obvious that gracehopper.sayQuote probably has to say a quote that's related to that object. Whereas if we just had function sayQuote sitting out on the global window, that doesn't really tell us much about what it's for. So over here, we have another method, and so this one's going to take in a name, and it's going to log out, hi, name, I am Rear Admiral Hopper. But this is pretty useless and redundant because we have this information already available on that object. We've got the last and we've got the rank. And so right now, what if down here I went and I said gracehopper.rank is equal to general? We would update the rank and it would be general, but later when we call greet, this would appear to be outdated information. A programmer would have to step in here and manually update this data as well as this console log to still keep it relevant. So instead, this would be a lot more useful if the greet function actually used the properties on Grace Hopper, rather than assume that she's always going to be a Rear Admiral. And not to mention, it's just redundant as well. So when we call greet Karen, we pass in the string Karen into this function. That's going to log out, hi Karen, I'm Rear Admiral Hopper. Make sense? So methods frequently reference other properties in the same object. And this is the example that we covered at the start of class. Over here, this is a little bit better because now we're always going to use the rank and we're always going to use the last property that are on that Grace Hopper object. So at least greet will be kept up to date as the data inside Grace Hopper changes. But what happens if we ever change this variable name? If we ever change this variable name and we still have a way to get to this function, it's not going to find Grace Hopper. This isn't going to still be the same object it exists on. And we would hit those errors that we hit earlier when user 2 could not say what quote or what say name because user was no longer that object. Does that make sense? But for now, this one works and it will say I'm Rear Admiral Hopper. So if on line 13 I said gracehopper.rank is equal to general, I call this function, it would evaluate whatever the rank is at that point in time. And this would be general, which is really what we want. We want the code to always use data at that point in time rather than hard code or make assumptions. The problem with this is that we've assumed that the variable Grace Hopper will always still be this object. So instead, there's this magic keyword we can use when we're inside of methods. When we're inside of functions on an object, if we use the this keyword, it will always refer to the object on which the method resides. And the way that you can think about this is that if we're calling this greet method, this is going to be equal to whatever the thing is that comes right before the dot. So when we go into greet, this is going to be whatever value Grace Hopper is. Or if you look at it this way, this will always refer to whichever object this function exists inside of. Yes?
So that's kind of to go with what you were saying earlier, where if the function here, or I'm sorry, if the object name like changed,
Yep.
this you wouldn't have to like redo the code if this there because it's already gonna go.
Exactly. It will always point to itself. And the way that you could tell who the caller was is going to be whatever thing existed on the dot. Whatever thing See, this Greek, this method exists inside of whatever came before the dot. So this will refer to that. Now, what do we think this would be out on the global window? No, close. But it'll actually be the global window. And you can think of it like when we begin to run your program, there's this window object and it assigns the functions onto itself. Like global scope is kind of like the overall window. And so when we're all the way out on the left, this just refers to the current environment you're operating on. There is no dot notation there. You're just already within the window. So it's just something to know. It doesn't necessarily make sense yet, but this keyword always exists. What?
Say that last time.
Which?
What you just said. It's something that always exists.
Yeah, that this keyword always exists, but sometimes it's a little tricky to figure out what it's currently referring to. So right now, the only thing you have to know is pretty much it's always going to be whatever called the function, whatever came with this dot. So inside of greet, this will be whatever Grace Hopper currently is. So over here, they've created this method called getThis. And it's going to return this, which is a reference. And this is why this is tricky. So to step through this, on line 3, when we go to create Grace Hopper, first we put space in memory called Grace Hopper. And now we start to evaluate this side of the equal sign. So as soon as we see this object constructor, we go over here in memory, we take the first available spot, and we're going to put that object right here. Okay, so we've created that object in memory. The constructor gives us back that memory address. Grace Hopper is now pointing to memory address 0, which is where this thing actually lives. Still with me? So, then later on, when we come over here to solve this, first we say, okay, returned object. We need to make some space for that. But I don't know what that is until I evaluate this whole side. So to evaluate this whole side, we first need to access Grace Hopper. So we say, do we have a Grace Hopper on our scope? We do. It's memory address 0, so let's go over to that thing. So we're now operating inside of this data structure. And because we're inside of this data structure, and we hit this function and we begin to evaluate this, now this keyword says, okay, whatever I am, just return a reference to me. This is equal to myself. So the getThis method, it sees that it's at memory address 0. It's basically going to return a pointer to the memory address 0. So a returned object is going to get whatever this was. And this was Grace Hopper. Does that make sense? See why tomorrow's lecture kind of makes more sense to go before this? I'm not sure how to explain this without going into all of this. And that's a lot of this. All right. So, right now, if I had line 13, what would it evaluate to if I said returned object triple equals Grace Hopper? Why?
It's the same for address.
Yep, exactly, 100%. So this method was basically just used to be able to get more references to the same object very easily. So returned object and Grace Hopper both currently point to memory address 0. Which means to evaluate this, we first need to look up returned object. We find it on the scope. We see its memory address 0. So we come over to this data structure, and when we access the first property, we get the value Grace. And now on line 14, if I go to compare whether these things are literally the same data structure, we see on the global scope they're both currently pointers to address 0, and this is true. So how do we make this a little bit more useful? How do we make an object that has methods that are actually useful and do stuff and update data over time? Well, we can pretend, you can imagine that your calculator is coded as an object under the hood, and it keeps track of what current numbers are typed in. So at the start of this program, we've defined a calculator where num1 is going to be 20 and num2 is going to be 30. And then we added two methods onto it that refer to the numbers inside of itself. So when we go to call calc sum, what is the value going to be of this? Just this. What is this? Just looking right here, how do we know what the this keyword is going to evaluate to? So the hint right here is just inside of this function, whatever came before the dot is what this is going to be inside of that function. So when we go into sum, this is going to refer to whatever calc currently is. And so when we go into sum, and now we look up num1, which is 20, and we look up num2, which is 30, we can return 50. Now, we're going into that same object, and we're saying num2 is no longer 30. Num2 is actually set to 15. And that gets updated in the memory address that calc exists at. Now, when I go back to the same memory address, calc, and I go to difference, this is also referring to calc. They're the same data structure. And so when we come in here and it says num1, it looks up, it sees num1 is 20, but num2 most recently has been 15. It's persisted those changes, and those functions will always use the most up-to-date value of that property on that object. Does that make sense? So now why this is really useful is because we can have a function that's just spitting out new calculators. So we can have 100 calculators all at once, but each of those calculators, while they're using the same code of their functions, each of those calculators will only use the numbers that belong to itself. And that's where the magic comes from. So there is a lot more to the this keyword. It is one of the trickier aspects of JavaScript. For now, pay attention to the dot. Whatever comes before the dot is what the this keyword will be. In 95% of cases that you're dealing with this, that's all you need to know for now. But JavaScript is an object-oriented language, so all of these data structures, they're all objects inside of each other, which means if you dive into some of the other aspects of JavaScript that you're not fully controlling, you might not be aware what the this keyword is because JavaScript has a lot of objects inside of each other and you don't fully know that environment. So it can get pretty complex, but we really don't need to think about that yet. We just need to know how it relates to the objects that we're creating and defining. So we're only skimming the surface here of this and object methods. There's a lot more to learn. All right, someone tell me what's a method? Yeah, why would we put it inside of the object? Yep. But why would we put a function inside of an object? Yeah, it should do some logic related to that object. And now, how does that function get access to the data on that object? The this keyword. Yeah, it sounded like a trick question. It's not. Yeah, no, I don't mean the technicals of how it does it. But yes, we use the this keyword for methods to be able to refer to themselves and know that they will get the correct data. So that was just a little intro to this. What is the main rule? How do you know what this is going to refer to when you're looking at an object? Yeah, so the example I mean by that, pretend that we have two calculators. We've got calc and we've got calc2, and they both look exactly the same. I made them out of a function. And so we've got calc1.sum and we've got calc2.sum. And we look at the code and we're like, we have no idea what this is. We look at the code for sum and we have no idea what this is. And that's because we won't know what this is until the function gets invoked. So at the time that this one gets invoked, on this invocation of sum, this will be this calculator object. If I had calc2.sum, when we called that sum, the code looks the same, but this would be calc2. That's very verbose. I don't know if that makes sense yet either. Okay. So, do we have any questions on that?
I have a question on what you just said.
Yeah.
Can you say that a different way?
Yes. So I'm going to use a real life example here to hopefully solidify this a little bit and show why it's actually useful and why we need this keyword. So to start, and then if I haven't answered your question, ask me again, okay? But I'm trying to answer your question right now. So the whole idea here is that I want some object that's going to hold all of the numbers of anybody in the world as well as their names. And so what I'm going to do for that is I'm going to use an object that I'm calling directory. But basically it's just an object where we have key and value pairs. And the keys are going to be phone numbers, which should be unique in the world. Your phone number should be pretty unique just to you. So one thing to know here is that when we use an object in this way, where we're going to have unique key and value pairs, it's called a hash. Not something to know really, but if you ever hear about hashes, it's just an object that's serving a specific purpose, where the key and value pairs are unique and they have a real life meaning to them. So in this case, the pair of a number and a name is unique to this person. I'm not going to put in the same number with a different value. Okay, so to represent this whole phone book, I'm creating one big object, and on that object it's going to have a property called directory, and that's what I'm going to use as the hash to store phone numbers and names, and that's the only thing that's going inside of this directory property, names and numbers. But because the phone book as a whole, I want this to have real life representation, to be like a collection that represents a phone book. So I'm going to add these methods onto the phone book to operate on itself. So, does anybody have any ideas on how we can implement this add number function? It needs to take the name, it needs to take the phone number and set that on the directory equal to the name. This dot, what was that? Yeah, this dot directory, that's where we want to store the numbers. So we're saying, hey, on myself, go to the directory property. This dot directory now evaluates to this object, this hash in here. Now, how can I store the phone number as the key? Yes, exactly. So this needs to work for any phone number I get in the world. I don't know ahead of time all the numbers I'm going to get. So dynamically, I need to evaluate what number you just gave me. It will plug that in when it resolves to this number, and then we can plug it into the directory. So we're now setting the key of whatever phone number it is on this phone book's directory. And that should be equal to what? Name. And so maybe if this was real life, I would probably have some other coding here where I first check to see if that number is already set, and I'll throw an error and say, hey, you can't overwrite somebody's name. But in the interest of time, we're just going to do the bare minimum here. Now over here, how can I remove a number from the phone book? Okay, we do want to delete. What do we want to delete? Okay. So I'm going to go an extra step. I want this phone book to be able to log out all of the names and numbers inside of itself. Any ideas on how to get started? How can I loop through a directory object? How do we loop through objects? Yeah, for in loop would be great. So our keys are going to be what? What do they represent? Okay, so for each phone number, inside of what?
Property directory. This dot directory.
Exactly. So if I just left it as in this, what would I actually get as phone numbers? Yes, so this refers to this whole object, right? It is an object, we can iterate through it, but it doesn't care that I called it a phone number. JavaScript doesn't know. It's just going to say, I'm going to go through each key and give it to you. So yeah, phone number would be directory, and then add number, and then remove number, and then log phone book. And because I knew I want to log out all these numbers, that's why I've isolated the actual directory to its own object. So yes, we don't want to log out everything in this. We want to do it for everything in the directory. How can I get a person's name now? Whenever I write a function or I set up a for loop, the first thing I want to do is I want to figure out how to access the data. So right now, I know I've got the phone number. How can I get a name? Yeah, I want to get this value. And I know I have this phone number.
So would it be like name and this stuff? That one?
Uh-huh. Is that it? Yeah, I'm going to dynamically get all of these phone numbers. So right now, on the first iteration of this loop, we're going to say, hey, go to this .directory and give me a phone number. And we get this number. And I need to get this value. So unfortunately, I have to go traverse the whole thing again. I have to go back into the directory and plug in the phone number. And this will result in the string Chris Rizzo. So now I know I have name. And actively debugging this, I would probably log out that all of my phone numbers and my name to make sure I'm doing it correctly, and that would actually do my work. But I know here that this should be correct, so we can say cool, that's all log phone book needs to do. It just needs to loop through all the phone numbers and log out the names and numbers. Great, so I initialize this phone book with a directory. And we want to see what it looks like right now. Great, we've got one person in there. How can I add a number? So we called that add number method, and it did go and it added the number to this directory. And so now when we log it out, again, we see that the directory has been updated. But yeah, like you said, push, technically, I could have went and I could do this all over my code. Every time I want to add a number, I could say phonebook.directory, new number is equal to whatever. I can do that, but I want to make this API, I want it to make sense and just work on its own. So I'm going to define methods. And basically, we've now created a phone book. This thing functions as a phone book. We gave real-life functionality to a JavaScript object through these methods. So the real reason of the this keyword is I want multiple phone books now. I want to have a phone book for USA, and I want to have a phone book for Europe. And when I go add a number to USA, and I log it out, or I log out USA phone book, I only want to see the USA numbers, not the numbers in the European phone book. So I need a way to generate multiples of these phone books. So we've kind of figured out the recipe already. Well, this is what the phone book should look like and how to achieve its functionality. I just need to return, I need a way to get multiples of this. So what we're going to do is we're going to make a function called createPhoneBook. And inside of that function, we can kind of store our recipe here. And we can return phone book. So what's going on in this function? As soon as we run create phone book, it makes space in memory for something called phone book on line 96. And we hit this object constructor over here, which means we're going to go to the first spot in memory, and we're going to save basically all of this functionality at memory address 0. Then down here, we're saying, hey, just return phone book. And so this phone book was actually in the local scope, but it's going to return phone book from here, and that's memory address 0. And at line 114, I had PB1 waiting for the result of create phone book. And so create phone book basically returned memory address 0. So PB1 is now pointing to that object over here, which is currently an empty phone book. Then on line 115, I do it again. I go in and say create phone book. So to better illustrate this time, as soon as we call create phone book, we make a new functional scope. And inside this functional scope is where we define phone book again. And so we go in memory to create something. So again, when we make a complex data type, it goes to the first available memory address. So now memory address 0 is still taking. So we go to memory address 1, and we make another phone book that looks kind of the same, except they're now at different spots. So in the local scope, phone book was equal to memory address 1 inside of this function. When we define phone book, we went to the next memory address. Phone book is currently memory address 1, and we return whatever phone book is, which is memory address 1. So out here where I had PB2 waiting for the result of this function, PB2 now gets what this was, which was memory address 1, right? Still with me on that, the functional scope in here?
Sorry, you lost me.
Does it matter that it's in one? 'Cause if I- just
No,
thinking
it
about the
doesn't.
way
And
that
I'm just saying one to signify that it's different than the one we had before.
if you
The
create-
one we created already is still in memory, holding up space. So when we make a new object, it goes to the next available memory address. And I'm just illustrating that this happens within create phone book, so it's on its own functional scope over here. At the end of create phone book, it says, hey, return whatever we know as phone book, which is now the object at 1. So that reference comes out to us as PB2. And we're done with that function, so we can delete that functional scope. Those objects we created inside of that function, they both exist in memory. And we've got their references out onto these variables on the global scope.
Which function can you delete when you just said leave that function?
I deleted the functional scope, which means basically, as soon as we hit the end of a function and it's done, it doesn't need to remember what that phone book was. It just says, hey, I'm done.
Gotcha.
Global scope is still there, that's persisted. So, yes.
Just to connect this with the array example that you gave us before, I'm just thinking if you were to mutate or change the directory's contents in, let's say, PB1, then when would it affect other things? Or if PB1, instead of writing let PB1 equal create phone book and then let PB2 equal create phone book, if you did let PB1 equal PB2, they would have the same memory point rather than these two
Exactly.
different, and then you would have be changing the directory in both of them.
Exactly.
Okay. But how exactly did this one end up with a different memory address? Why did this one get the one? Because
Yeah.
one was local. I'm sorry. I know. If I'm slowing people down, I can.
No, that's a great question. That's what I think we're blanking out on right now, and it's hard to explain this at first, especially because we cover pass by reference tomorrow. But when we come into this functional scope, every time we start a new instance, it needs to process all of these instructions again. It doesn't know that this has been called 100 times and has already made 100 different let phone books. Every time we call this, we get a brand new, fresh local scope. And we say, make some space in my local scope for something called phone book. And we've got this object constructor here, which tells JavaScript, go find me a spot in memory. And when you put this all in that memory spot, give me that memory address. So we went to the second time we called this function, we're now creating phone book. We need to create an object. We go to the next memory address, which is memory address 1. And so now we say inside of here, phone book is pointing to memory address 1. And when we return, we're basically saying, hey, return memory address 1. So that address is what comes out to PB2.
So I think that was the confusing part, right? Because when you're looking at it and it says return phone book, like you're thinking about the code that's before it, but when you're saying return phone book, you're actually saying return the memory address
That I just created. Yes, that's the difference. If I had phone book sitting out on the global scope, it only gets created once as we go down. So as soon as we have this equal sign and this curly, that's when we create space and we put it in memory. And because I put that inside of the function, every time we call the function, we make new memory space. If that was out here like it was before, all of the phone books are the same. It doesn't matter if I keep saying PB1 equals phone book, PB2 equals phone book. That phone book was only created once. It's only one memory spot. By putting it in a function, I can make sure it happens multiple times. And I could generate new objects at new memory addresses with the same functionality.
Couldn't you write the function to give a different name every time?
I'm sorry?
Couldn't you write the function to give a different name every time?
So what do you mean by give a different name?
To give the created object a different name each time. So you wouldn't have more than one named phone book, but it would automatically name it phone book 1, phone book 2.
Well, we can't actually write code that generates variable names. So there's just no way I can dynamically do that. But in the end, JavaScript doesn't care about what the names of the variables are anyway, so the name has nothing to do with it. It's the fact that when we construct it, it makes space in memory. And so by putting it in the function, I make sure it gets constructed many times, which is how I get multiples. So if we did pb1.add number, phone number, name, yep. How many names and numbers do I expect to see on line 118? Yep. Which one?
Whatever, yeah, 1, 2, 3.
Yep. So what happens if I do this? Why?
They're different memory addresses.
But they came from the same code. They look the same to me.
Yes.
Yeah, they actually exist in different places. They came from the same idea. They do the same things, but they're totally separate copies. So I can now have many different phone books. And this is how most of your applications work. Like Facebook, it's creating a new user object every time we sign up. And there's one big directory that has all of the users in Facebook. And some people will know a user as best friend, and others know it as the logged in user, and others don't see some of the other users at all. But by sharing references, we can persist the state of the application to be predictable and make sense. So this keyword is what makes this possible. Otherwise, I kind of would have to I'd have to copy and paste this code over and over to make new phone books and to point them directly at their own variable and never change the variable. This keyword lets me do it just once, and any instance of that object will only know itself. Okay, that's a lot. I hope I didn't kill all of the confidence. We will get some of it back tomorrow when we go much more in depth in pass by reference, pass by value. I just honestly have no clue how I can explain this without trying to draw all of the memory, because if I explain it in one way without going over the references, as soon as I bring it up tomorrow, it seems like today was totally useless. So we're not going to get too hard with these methods today, but more so, are you able to add a method? Are you able to define a function on an object? And do you understand how to access data on that own object? They're going to be a lot more simple. You're not going to need to write a function to generate objects or really get into what we just did. The main takeaway is using this keyword to refer to itself. And what's the hint? how do I know when I call add number? How do I know what this is going to be on that invocation? Yeah, so when I call add number on 117, PB2 is what came before the dot. So when we go in here that time, this will refer to whatever PB2 is. And when we did it for PB1, it's going to the same code, but this will be upset, will have already been set to PB1, whatever memory address that is at. Any final questions? Cool. Well, that's a long one, but hopefully tomorrow will go smoother now that we covered half of it. We just got to do a bunch of examples and hopefully solidify pass by reference versus pass by value. But yeah, 5-minute break and then let's do workshop.